So a week ago, Tuesday, I decided to do a talk. Well, I decided about a month ago to do this talk, but a week ago I had to choose the topic. So I chose the topic, and then I did all the work. And then I realized I have 2 talks that I've made. So, so this is part 1. So I wanted to cover lessons learned with combining together MVVM-C and RxSwift. But honestly, the RxSwift half of it takes up half an hour. So hopefully I can do the next Tacow and do the second part of it, okay? All right, so what is the purpose of this talk? I want to raise awareness of some of the potential pitfalls that I've identified with using MVVM-C and or RxSwift, and give strategies for avoiding them or reducing the downsides. So the purpose of this talk is not to discourage using MVVM or RxSwift. Like any architecture can have any pitfalls, so for whatever we're using, we just have to learn how to address them, right? So who's the audience for this talk? So RxSwift has a noticeable ramp-up time. So I'm targeting developers who already are a bit intermediate, maybe, and already are familiar with some form of reactive programming. If you've never done any reactive programming, you might just be a little lost here. And for the second part, anybody who's just interested in exploring MVVM-C or the combination of it. Okay, so here's the background of where I learned these lessons. So I've been working on a project that used MVVM-C and RxSwift for about 2 years. Now, what is MVVM-C? Why do I keep saying these letters? So instead of MVC, it's another architecture that's model, view model, coordinator. And obviously I'll get into that more in the second talk, but all the code examples are of the combination of these. And RxSwift reactive programming is kind of a fundamentally different way of programming, where instead of calling code and sort of the flow kind of pushing from one line to the next line, it's like you set up these streams and you let data flow through the streams through your program. So it's more about kind of pre-wiring these static relationships and then letting it flow. So we had to get used to that paradigm in these 2 years, right? And the team had to learn MVVM-C, had to learn RxSwift. And we had 2 native applications, iOS and Android, that were being made in parallel, all of us collaborating. And the app talked to IoT devices, and where any state could change at any moment. The device could initiate some activity, so it could just push data to the app, or the user could interact with the device, or you could just have another smartphone that's also talking to the device. So you couldn't have some sort of architecture that assumes like I did a user interaction and then things happen due to that. That just wouldn't fly. So the app talked to the device over Bluetooth and an open persistent WebSocket connection, and also talk to the cloud. So those are the kind of key data flows come from those. And then, so everything is asynchronous, state is constantly changing, and the state needs to update throughout the app. You don't want one part updated and other parts out of sync. So just getting into the architecture as the MVVM-C and the Rx relates to each other. So we mostly had an aim to have very simple view controllers and put most of the logic into view models, managers, and services. Everything was connected together, though, with Rx streams. And so we tried to do a certain amount of TDD. So the view models, the managers, services were all covered by unit tests, and we used dependency injection for everything. We used protocols for everything, so we could mock out individual pieces to unit test things in isolation. Okay, so part one, the Rx potential pitfalls. Okay, crash reporting. So if anybody who's looked at a stack trace from using Rx programming, you'll see that it was like, it's kind of hard to tell, like it's long and painful, and it's hard to tell why this code is being called because you've separated out the wiring from the actual flow. So, and you have these long stack traces, like let's say like 150 is not a lot, that's like average in our app. 150 line stack trace, first couple, last couple are relevant, and then you're scanning through this whole stack trace to see if any of your code is in there or if it's just Rx operators for like, you know, the 140 lines. And so I just want to compare and contrast a standard network fetch with a completion handler versus a fetch and that then broadcasts responses. And really this broadcast model isn't Rx specific. If you were to use a delegate or a notification center or Rx subscriptions, you'd have the same concept where it's, again, you pre-wire listening and then responses come in. Leads to very different characteristics for stack traces, for crashes than with completion handlers. So let's look at the completion handler. Okay, so I have this function, do it, and it calls our service retrieve count and it gives a closure. And then the service is dealing with some kind of model thing. So I'm just using an int to differentiate it from the network layer. And the API download is doing our networking, and it has a completion closure of data. And it calls the data task, and that takes a completion closure. So each one calls inside of a completion closure another completion closure. Okay, so, and that's very typical, classic infinite nesting of completion closures. So what's our stack trace look like if do it crashes, like our print, something about it, or around that line was crashing? We'd see that the stack trace crash would show the run loop, and then it'd be calling through the URL response layer as it's dealing with the response. And then we'd see that we're in API download inside this closure, you know, at the line where we're calling our completion closure. And then we'd see that we're in the service in its completion closure, and then we'd see we're in do it. So even though the response calls are coming, because we passed them in from the requests, you can actually see, you get the idea that I'm doing an API download, but you see who called it in the crash. So you get an idea of that calling context. Now that's in contrast to when you do a network fetch and it just broadcasts out to some kind of pre-wired listener where very similar code. This is, so do it calls the service retrieve count and subscribes to it. So it's using a subscription instead of a completion handler. And the service is really just taking the API thing and mapping to a model. So this might be like parsing JSON or whatever to a model object. Here I'm just mapping to the count of bytes in the data for the example. And then our API, again, is essentially using an Rx helper from RxCocoa off of the URL session. And I've got some error handling that was in the previous example in this, where if there's any exception, we just have empty data. So we'll see, though, there's a fundamental difference here where we have commonality at first, the run loop, URL session, and then we've got who knows how many lines of Rx operators. But then, yeah, the stack trace doesn't involve any of these other layers. And in fact, even our map that's doing work, that's not in the stack trace, because as the data streams through the operator, it calls that closure and it returns, and then that result is passed through the operator chain. So it's not a part of the stack trace. So yeah, it can just be a lot more opaque about what's involved when you just end up with a stack trace. But again, that'd be the same thing with the delegate, notification center, listener lists, any other kind of thing. So lessons learned. So I learned that what I want to do is actually customize the Crashlytics reports by using the APIs it has to log to Crashlytics as the user does their actions and as other parts of the code are doing their flows. I'm going to use their APIs to log to it, and those logs only go out if there is a crash, but it's bundled with the crash report. So suddenly now, instead of just this opaque stack trace, I'll see on another tab in Crashlytics, I'll see like, here's what happened and leading up to the crash. And now I can reproduce it, which is like the huge thing to try and solve, right? Okay, another issue is observables everywhere. So you start writing Rx code, and then it seems like there's just, you're declaring subjects and observables and all your objects all over the place. So I'm going to describe each of these individual things. So we had a bit of a purist approach. We're creating an API intended for other uses, for multiple apps, not just the one app. So we wanted to be really clear about things like declaring that something is an input and an output intentionally. So we used a lot of type erasure. And so this isn't wrong. It's actually, maybe it's right, it's correct, but maybe in the aggregate, it's like too correct if you just see all this type erasure and doubling the code. So what am I talking about? I'm saying that learn more bun event is a published subject, it's public. So I'm saying I'm gonna input into my class by people publishing to this event. And then anybody who wanna like subscribe to that or read to it and know that these are happening, so maybe my view controllers, this is on my view model and my view controller is publishing, but maybe like my coordinator is subscribing to this and then showing like my Learn More UI. So now I've got this other observer, type erased any observer that's derived from the published subject. And so it's not really necessary. I could have just, both sides could have just directly used the published subject. So we're just trying to be purist and doubling our code, so I don't know if it was worth it. The other thing is that these are fine-grained. I'm like, this observable string is only when you do the learn more bun is pressed, and this one's if you do the open bun event. But again, maybe I could have been a quarter of the lines if I didn't do type erasure, and I just did one stream and emitted like an enum to say what kind of bun was pressed. So depends on your needs. Either are technically correct, but so on a similar vein, so these were inputs and outputs. Now here's where I'm not disagreeing with this approach, it's heavy, is that we had things where our publishing, so our writing was like inside the view model. So we made it private, and then, but we want to output those so somebody could listen to it. So then we create this observable and we hide that was a published subject. So now what was just, a line has become like 4 lines, and you just multiply that out. So, and then again, here it's like the Bluetooth connection, like it worked, and then here it wasn't allowed. So do we need multiple streams for that? Or again, I've used some sort of result object or an enum or something to just like divide this down. Okay, and then here's a really interesting thing. Like, this is actually my fault. So, so we have statefulness. So, with Rx, you want to stream data and you want to kind of avoid holding data. But we're like non-Rx people learning to do Rx, so we're doing a lot of holding data. So we created our own thing to hold it. So we made this observable field thing. So it's like you can publish to it, you can observe it, but you can also just, like without setting up an asynchronous thing, you could just like call its state field and just get it. If you're in a function, you just need to use the value. So when we did our type erasure, it was like, well, if I become an any observable, then people can only observe it. They can't get this state, like synchronously, just grab it. So now we have to do type erasure where we create our own concept of an any stateful observables, which lets us still do this state thing. So it just, that whole thing had to be made. And yeah, why not just make everything just be observable field? Well, in this case, it's because, well, any stateful observable is read-only. So yeah, we're being purists and controlling the write access. Was it worth it in the end to be so purist? I'm not sure. And then we're just like, we're RXing everything. So even this like constant that we load of a localized string that will like not change for the app, we've like, that we're kind of like statically emitting, it's like we've just RXified it. So yeah, we can bind it just like everything else. We can just keep the app super consistent and not special case. Some things RX, some things not. But then the user of this has to do a bind, and it's just more lines of code. So so what are the lessons learned? Use fewer streams that pass thicker data, like if I'd passed the enum or some more complex data structure instead of just a whole bunch of void streams or simple data structures. Type erasure to hide subject implementation details. I personally don't think it's worth the code load. But if we really had to do it, and you know, to manage the read-write for like a good API, I think now with Swift 5.1, I would investigate using property wrappers to generate this code. So the code will be like terse and simple. It's just, all this was done before Swift 5.1. So, and I might possibly prefer just calling functions instead of having these input streams. And I think that might simplify things. So, okay. Is this legible from a distance? Sort of. Okay. So basically, the problem here is that if you think about, this is an app update manager. Its job is to say, okay, what version is the app now? What does the backend say is the current version? And compare that and say, do I show like a UI to the user to prompt them to update? Like remind them maybe they should turn on auto updates like a normal person. Anyway, so it exposes an event that some sort of coordinator is listening to show that UI. And it's based on something that was injected that says when to do this work. Like maybe the app got foregrounded or something, you know, some user interaction that was like, oh yeah, let's check the app version. And it's very standard, correct Rx code if you know Rx. This is like at a glance, I know what this is doing, but if you asked me, you know, a year and a half ago, I'd be sitting there line by line trying to figure this out. And then yeah, there's calls some stuff to actually do calculations. So what am I complaining about here? I wouldn't actually know to change anything here to make it better. Well, the problem is regardless if this is like maybe not super improvable, it's like I'm still gonna complain about it to all you, is that like half my code is dependency injection, like all my things I'm using because we're following solid principles, single responsibility. So now I've got just tons of little things that, yeah, they're unit testable and great and understandable, but now half my code is just taking them in and storing them. We've got all these nice, simple, single-purpose functions like fetch manifest that like, okay, cool. I fetch the manifest and I get one response, a single response. But it's like there's no one place with just doing the work. It's kind of scattered and maybe like 3 lines of code in this whole page do what I'm talking about. So that's, and it's not adjacent to each other, you know, like part of it's in a read-only property, which I puristically don't want to put with my functions or whatever. So it's just, there's a learning curve is the point here. It's just done differently. It's not bad, it's just, so learned. Just refactor or document any complex or non-obvious Rx. Like, there's, like, I've got mark statements, there's no documentation here. That's our app. It's just like, you better know what zip and flat map latest does. Otherwise, you don't know what this does, how it does it. And just really like be cognizant that what's obvious to an experienced Rx developer could be like totally opaque to a less experienced one. So over document maybe hows and whys this is even working. Yeah, and maybe just be careful about using like all these little observable properties, little functions, little thing where it's just not together and like I can't even see it on the screen together. I have to scroll like, and so it just could be really hard for someone to kind of put it all together cohesively. Okay, I want to introduce a topic that if you don't know Rx, I'll just be speaking Martian to you right now. But anyways, there's this concept of cold, hot, and lukewarm observables. Okay, that is just a major pitfall. So if you're going to do Rx, learn these is like the number one learning. But okay, so I'm going to invoke a function that returns a cold observable, and it won't do anything until there's at least one observer subscribing to the result. Okay, and then as you add subscriptions, it will actually do that code per subscription. So in this case, this is code I copy paste from RxCocoa and cut out logging and whatever. This is the code that you would, if you're using the URL session Rx helper to get data, and this is how it's implemented. So per subscription, that's what this observable create. Everything in here happens per subscription. It does the actual network task and returns the results. So if I'm doing a network call and I want my whole app to update, so maybe I make a couple subscriptions to that. I want to do my main UI, the sub UI, my master, my detail. Per subscription means that many network calls are happening if I just straight up use this cold observable. Okay, so what is hot? Hot. So invoking a function that returns a hot observable will always do the action once, regardless of how many observers subscribe to the result. Okay, so kind of the opposite. And this hot observable can emit, even if nothing's observing it, it's trying to emit. So I created this timer thing, and as soon as you call observe ticking, the timer will just start, and it'll just every second it will try to emit to the observable stream. So I can see due to my timer fired code that it's running. So I make my metronome, I call observe ticking, I'm not even observing, and we see it boom, 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 emitting. Now I observe it and print receiving. So now timer fires, received, timer fires, received. It's 1-to-1. And I add a second observation, a second subscription, and we see what we expect with a hot observable, that the timer fires once and then each observer per. So I don't get 9:41:15 twice because I have two observers, just the one time. Whereas a cold would do the 9:41:15 twice because I have two subscribers. Okay. Lukewarm is this weird in-between thing where I start with something that's hot, and then I chain in an operator like do. Do is like a way of doing side effects in our chain. Sometimes people do logging or call analytics, or it's just like a side effect that's not like the purpose of the subscription. And just so I add it, and before, remember, so it's the do and below that's affected. So the above is still hot. So we're still called observe ticking, the timer's still firing, but in the absence of a subscription, because this is commented out code, do is just not doing its closure. Now I add a subscription and we see that the do is doing and the subscription is receiving. So it turned a hot thing cold below, like at and below it. So we call that lukewarm. Okay, so hot, cold, lukewarm. What are the lessons learned? So because the code that's running in those observable creates and maybe in your cold operators and everything, all of those affected by your subscriptions and the number of subscriptions, you have to unit test different numbers of subscriptions to actually be sure that your code is correct. So you can't just do like some simple unit test with the one subscription and No, you need it with 0 subscriptions, 1 subscription, n subscriptions. Test all of those, and then you'll like be sure that your code is actually correct. And I didn't talk about the shared operator, but basically it is a way when you have these colds that do all these work, it's a way of sharing it between the various subscriptions. So anytime you're doing IO or extensive processing, anything that you want to be happening this one time, you probably need to use shared. So just always be thinking like, do I need shared? Do I not need shared? Like it's a question to always ask yourself. Okay. I hope I can explain this way. It's kind of abstract in my mind, but so has anybody seen an Rx marble diagram? Can you raise your hand so I know if this is, okay, awesome. So there's this kind of visualization of like streams and data flowing through the streams over time. And just a lot of example code tutorials, they might use these Rx marble diagrams to explain how operators work and subscriptions. So, they're always simple. There's like, here's a little int, here's a little string, a little bool going through there. So it's all like, the examples are simple. In our app, we actually found that our data is more collections. It's not single instances, it's like collections. And so I'll call those snapshots. There's like the entire collection of data you're tracking at a moment in time being emitted through the stream. And then something mutates that, and then we're sending the entire collection. And so in this example, you'll see I first start with like an empty array. And then I move to having an array with A. So I've added A. And then I go, the next element, the next snapshot is A and B. So I've added B. And then here my A is gone and I've got a C. So I've kind of replaced A with C, right? So the question is, do you emit these snapshots of your entire collections, or do you kind of emit these mutating actions like this is what's happened? Because marbles seem to indicate you should be like, this thing happened. Well, the reality is you often just need both. You stream the snapshots and then you're doing diffs on them to see what happened to the collection. Or you stream these mutating kind of events, and then you need to collect them all up to know what is my current like state of affairs. So learned, basically, thank God for Swift 4.1 automatic equatable synthesizing. So if you're just passing like structs or collections of structs or whatever, or your model objects, then it's very easy to do the diffing. So you can just emit your whole collections, diff them, find out what changed, reason on that. If you're emitting these kind of mutating, like I showed add remove, like maybe don't make them so abstract, tie it to like a user event or like some real world thing that happened. So when you're logging, your crash logging, your analytics, your whatever, you're debugging, you have a much better sense of like really what happened in that stream. And then who knows, just do it all. So maybe put tuples where you've got your snapshot and the mutation that just created that snapshot. So you just have it all and you're not constantly recalculating at every subscription of that stream. And then you can also think of like what needs to act on changes like deltas. So if some layer, as you go, some layers on the stream need to just do the deltas, then they could take those change operations, and then when you end up in a UI layer, maybe it has to show everything. So it's where it accumulates. So maybe there's a couple strategies. Error handling. So here's my #1 problem with RxSwift. I love Swift. Swift is safe by default, okay? You have to deal with optionals. You have to deal with try. I try to only code exhaustive switches. And then RxSwift is unsafe by default in the sense that every stream can error, but there's no compiler warning or error or anything like that telling you to handle the errors. They just, by default, you can just not handle them and they'll just silently kill the stream. So here's an example where I did that network call, and on my subscribe, I have my on next where I'm dealing with the data, and it's a separate closure to deal with errors. And you just don't have to specify it. It's like, you know, it's like the default value of the parameter is nil closure value. So you just omit it and it's all good. And then when networking has a problem, just the subscription dies. And you're like, oh, okay. So let's compare that to Combine or reactive Swift that Combine is derived from, where those actually, the error type is like genericized. So the stream is genericized over the data and the error, whereas in RxSwift, it's not. It's just not part of the typing at all. So RxSwift, here's two versions of download, right? One version of download, I just do the networking. So it could error or it could have data. So my type is just observable data, nothing about the error in the type at all. Here's another version where I actually catch the error and return that empty data. So this stream returned from this function cannot error. It will never error. But that type, just nothing about it's different. There's no indicator to calling code that that's been handled. Whereas in Combine, our two version of download, the download, a little bit more code because of the erase, but anyway, so this thing, it's typed any publisher data error, and I can say what kind of error too. It's not just error, it could be specific error. And then this version here where I've done my replace error, so the equivalent, now the type is changed to never. So anything subscribing here can actually know that this stream cannot error. So yeah, so RxSwift actually, it's the things that came before it and after it have genericized the error type, and they just chose not to. Okay, so often you actually need a stream of error objects. So if you error stream, it kills it, it's dead, it's done. So what happens if I got like a login form where you could type in your password wrong several times, right? And I'm trying to listen to that to do some processing. So yeah, I need like an actual observable where the data is error. So here's an example. I've got a view model. I'm doing all my fancy type erasure where, you know, I've got my published subject is private, and so my view model is kind of going to publish to that, and other code can now observe this, and somewhere in my view model I call this function and it publishes that error, right? And then here's my coordinator, that the coordinator, it builds the view controller, it builds the view model, wires them together, and it will listen to some events from the view model to know about navigation. So in this case, it's showing an error banner when it couldn't connect. So this is the MVVM-C. Yeah, so it's just a typical thing. This isn't like a problem. This is more of a solution, actually. This is just a common pattern that you'll just have to emit data of error. So cool. Okay, so what have we learned from error handling? We just have to explicitly plan to architect how errors will propagate and be handled in the system. We can't let it be handled later. We'll get there, we'll do the happy path now, and then we'll sort out errors later. Because there'll be no compiler help, there'll be nothing. You'll just have like tons of code that doesn't do error handling. So up front, what is the plan? There's some tools. There's this relay thing where we can connect streams to long-lived strings without propagating errors. There's a couple of things. We just have to unit test the error cases, like TDD or whatever. Create your view model, your spec. Just plan what the errors are, unit test them. And you probably want to automate testing with like edge scenarios, like slow network, other stress scenarios. Just anyways, like even if you're not using anything I talked about in this talk, but I think specifically with this too, if you're using Rx, you just gotta push your app through the error scenarios. And then log, I'm saying Crashlytics, whatever you're using, but log errors to both analytics and Crashlytics, because you can get these errors, but it's not going to crash your app. It's just going to silently kill things, or just silently be lost, or silently ignored. So it won't be a crash. So the only way you'll know about in production is through analytics. Okay, so thank you very much. My mic is cut out. Okay. So next time I'll cover the MVVM-C pitfalls and other things like dependency injection and whatever. But thank you very much for listening to my very long talk. Any questions? Okay, so there's a lot of pre-wiring. We'll call it declarative programming, is like how the happy way it's called. And does that affect our ability to like be agile and change the code over time? And it actually allows the code to be very adaptable, I find. Sometimes when we use these other things where we're using delegates, we're using notification center, we're using functions, we're using all these different paradigms, it's actually really hard to kind of glue them together. But with these streams, anything can be glued together. We can map, you can really just very effortlessly change the code. So I say it's more agile. And that it is its own danger that we can maybe like forget to architect because we can just make it so. So that's like its own trap, but yeah, it's very agile.
Curious if you'd ever tried, I think it was like the point-free Kickstarter guys who have used the style of making a protocol for your remodel inputs, remodel outputs, and then the remodel conform set. Did you try that, or did you just find that's too much ritual, kind of similar to what you were showing of like having a published subject and then also having an external facing property to pass into just an observable?
Yeah, so we looked at like two variations. So one was that we just have a protocol for inputs and a protocol for outputs, and the other where we had a like inner struct for input and an inner struct for output. It added a bit more, and it tended to mean that we couldn't just declare everything in line. We'd have to do it all in the initializer. So it actually really like bloated the code a lot. So I think a couple people put it in and gave it a go, but it never became broadly used due to that.
When you did that, I'm just curious, did you make your inputs observables as well, or just like plain old functions?
Yeah, so we've consistently kept all inputs input streams. It's my view that maybe sometimes that can lead to this like endless declarations of streams, but we've very consistently kept public subjects as inputs. Cool. Okay, thanks.